In this problem, I need to solve for theta. And I'm going to start by looking at the sign of 4 theta. And I can rewrite this using the double angle formula. So in order to do this, what I'll do is I'll copy down sine of 2 theta plus, and now the sine of 4 theta I can rewrite as 2 times the sine of 2 theta times the cosine of 2 theta equals 0. And the reason why I didn't want to start breaking down the sine of 2 theta right here, I wanted to keep that the same, just bring down the plus, and then break down the sine of 4 theta, is because then I wanted to see if it was going to be possible to not have to break down sine 2 theta here, sine 2 theta here, and cosine 2 theta here. And it is actually possible, because what I'm going to do now is I'm going to factor out sine 2 theta because that's in common. So I have sine of 2 theta times, and now for my first term, I factored out the sine of 2 theta. That's all that was there. So I have a 1 left. Just keep in mind, you don't just drop that term altogether. You never just drop a term. We started off with 2 terms, so since we're taking out a common factor, what's left is going to have 2 terms. Now, again, we factored out a sine of 2 theta. That leaves the 2 and the cosine 2 theta. So now sine of 2 theta times the quantity 1 plus 2 cosine 2 theta is equal to 0. So that means I have 2 things that are multiplied together that multiply to make 0. And from algebra we know that that means that one of them is equal to 0 or the other one is equal to 0. So I'm going to have to set each of them equal to 0 separately. I'll start with sine of 2 theta. So if that is equal to 0, what I have to do is think about, well, what are some angles that the sine of that angle is equal to 0? And I know one possibility is that 2 theta is equal to 0 itself, because the sine of 0 is 0. So maybe 2 theta is 0. And then you take the sine of 2 theta and you get 0. Now, what else will work for this? The next time that the sine of an angle is equal to 0 is when we go to pi. So 2 theta might equal pi. And where's the next place that the sine function can equal 0? Because I have a double angle here, because this is 2 theta, I sometimes, well, pretty much every time, I'm going to have to go past what we normally do. So if this were just theta, then I would just stop with 0 and pi, because I wouldn't get another value on 0 to 2 pi. But because it's a 2 theta, there are more possibilities. There's actually 2 more possibilities. So the rule of thumb here is that if you're working with just 1 theta, then you just look at 1 cycle, 0 to 2 pi. And if you have sine of 2 theta, or whatever the trig function is, but if you have 2 theta, then you look at 2 cycles, so 0 to 4 pi. And if you had tangent of 16 theta, then you need to look at 16 cycles and you need to go to 32 pi. So thank goodness we're not going to ever do that. But 2 theta comes up quite a bit. So we need to keep going. And I have 2 theta equals. Now the next value where you get the sine of this angle equals 0 is at 2 pi. And then the next one after that is 3 pi over 2. Oh, don't want to say 3 pi over 2? No. At 3 pi. Here we go. So 2 theta equals 3 pi. So those are the 4 possibilities here. And now I'm going to solve each one of those for theta. I get theta equals 0. Theta equals pi over 2. Theta equals pi. Or theta equals 3 pi over 2. So I have 4 solutions so far, but I've only really worked with one of the factors. Now I have to work with the other factor. So for this, I'm going to let 1 plus 2 cosine 2 theta equals 0. And I'll solve this for the cosine of 2 theta. So I get 2 cosine of 2 theta equals -1. And cosine of 2 theta equals -1/2. So now I need to look at what angles can I take the cosine of and get a -1/2. Well, what I know is that 2 theta then is in either quadrant 2 or quadrant 3, because those are the 2 quadrants where the cosine can turn out negative. And realize that, again, we have 2 theta. So we're in quadrant 2, and then we're going to go a whole cycle around. So we'll still be in quadrant 2, but we're going to go a whole cycle past where we normally stop. So let's start with what is the first angle that is going to make this true. And so I say, well, 2 theta, let's see, if we look at our unit circle values, then we know that this is 2 theta. When do we get the cosine of 2 theta equals -1/2? Well, that's where the x value is -1/2 and the y value is square root of 3 over 2. And so that tells me that 2 theta has got to be equal to 2 pi over 3. Then I'll look for the angle in quadrant 3 that gives me the same result. And so that would be where 2 theta equals 4 pi over 3. So now what I can do is say, well then 2 theta equals 2 pi over 3, so theta equals pi over 3. And if 2 theta equals 4 pi over 3, then theta itself must be 2 pi over 3. And I need to go around a whole nother cycle here. So let's see, I can do this. Okay, so now I'm ready to continue this problem. And so far I've found that 2 theta is equal to 2 pi over 3, or 2 theta is equal to 4 pi over 3. So now, next I'm going to say, well, 2 theta could equal the quadrant 2 angle that is coterminal with 2 pi over 3. And so I find what is that angle by taking the 2 pi over 3 and just go ahead and add a 2 pi onto that. And notice that there's a lot of 2's going on here. So why don't I just go ahead and divide by 2 and get theta equals pi over 3 plus pi. So what is that? That's 4 pi over 3. There you go. So now, the last one we have is 2 theta. Well, it could equal whatever angle is coterminal with 2 pi over 3 in quadrant 3. And so I'll take 2 pi over 3 plus a 2 pi. And again, I'm going to divide both sides of this equation. Oops, I have the wrong one there. Let's see. Four pi over 3 plus 2 pi. Okay, so if I divide each term by 2, then I can say that theta equals 2 pi over 3 plus pi, because I'm just dividing both sides by 2. And 2 pi over 3 plus pi tells me that theta itself is actually equal to 5 pi over 3. So I just got the common denominator, 2 pi over 3 plus 3 pi over 3, and then 5 pi over 3 is my answer for that. Okay, so now I have all the solutions that I need. So I'm going to write these as one group of solutions. Okay, so now I can see that I have the solutions 0, pi over 2, pi, and 3 pi over 2. So let's start with that. And now what other solutions did we get? We got pi over 3 and 2 pi over 3. So these are not in numerical order, and they don't need to be. I mean, it's kind of nice if you do it. Doesn't mean you have to do it. And so my other two solutions are 4 pi over 3 and 5 pi over 3. And those are the solutions to that equation.